In this example, I'm given two functions, f of x, which equals the quantity 8x plus 9, all divided by x squared minus 4, and g of x, which equals the quantity 7x plus 7, divided by x squared minus 4. I need to find two new functions, f minus g and f divided by g, and then determine the domain for each function in interval notation. Well, quickly reviewing, here are the definitions for the sum, difference, product, and quotient functions. And in part A, I need to find the difference function f minus g of x. So by definition, f minus g of x is just equal to f of x minus g of x. Now I need to substitute in the definitions of both of my functions, and the first time I use a function, I always put it in parentheses. So I have 8x plus 9 divided by the quantity of x squared minus 4, that's f of x, minus, in parentheses, g of x, which is 7x plus 7, divided by the quantity x squared minus 4. So I'm going to have to subtract fractions. To do that, I need a common denominator. Luckily, both of these denominators are the same, so that is going to be my common denominator of x squared minus 4. Do I need the parentheses in the numerator of the first term? No, I'm going to have 8x plus 9. But now be careful, in this one, I'm going to have to distribute in that negative into that parentheses. That's why these parentheses were very important. So when you distribute in a negative, you're just going to change both the signs. So I'm just going to get negative 7x minus 7. Now I have like terms in the numerator. So I have 8x minus 7x is x, and then 9 minus 7 is plus 2, all divided by x squared minus 4. Can I reduce anything? Not yet. But remember, the denominator is going to factor. My numerator stays the same as x plus 2, and then x squared minus 4 in the denominator, that's the difference of two squares that factors to x plus 2 times x minus 2. Now, x plus 2 is a common factor of the numerator and the denominator, so it results in 1 divided by x minus 2. So that is my new function f minus g of x, my new difference function. Next, I need to find the quotient function f divided by g of x. And by definition, that equals f of x divided by g of x, provided g of x does not equal 0. So in this case, it's going to be f of x divided by g of x. And what is f of x? It's 8x plus 9 divided by x squared minus 4, all divided by g of x, which is 7x plus 7, divided by x squared minus 4. And we're going to take care of this restriction when we look at the domains in a few minutes. So now, to simplify this expression, how do you divide fractions? You take the fraction in the numerator, leave it alone. So I have 8x plus 9 divided by x squared minus 4. You multiply it by the reciprocal of the fraction in the denominator. That means just turn this fraction upside down. So I get x squared minus 4 divided by 7x plus 7. Now the x squared minus 4's reduce, and I get left with 8x plus 9 times 1, which is just 8x plus 9, divided by 1 times 7x plus 7, which is 7x plus 7. Does anything reduce here? No, I can't reduce anything. So that is the definition of my new function f divided by g of x. Or I could have written the denominator in a slightly different form. I could have written 8x plus 9 divided by, I can factor a 7 out of the denominator, and it's going to give me 7 times the quantity x plus 1. Both of these are totally correct answers. So now I need to go ahead and look at the domains. There are two different methods for finding the domains of our new functions. One is to look at the unsimplified version of each function. The second method works with the domains of f and g. That's the method I prefer. So looking at our functions f and g, are they going to have domain issues? Yes, they both have variables in the denominator. But luckily, both of the denominators are identical, so the domain of f and g are going to be exactly the same, and it's going to be all real numbers. Remember, that's the symbol for all real numbers, except those values of x that make x squared minus 4 equal to 0. Solving this little equation, x squared minus 4, difference of two squares, x minus 2 times x plus 2 equals 0. Set each factor equal to 0, x minus 2 equals 0, and x plus 2 equals 0. From the first one, add 2 to both sides, x equals 2. From the second one, subtract 2 from both sides, x equals negative 2. So those are the two values of x I have to exclude from all real numbers. The simplest way to write this in interval notation is to graph it quickly on the number line. And negative 2 is on the left of 2, so here's my negative 2. Here's my positive 2. I need everything to the left of negative 2, everything between negative 2 and positive 2, everything to the right of positive 2. So I have three different intervals. The first one is negative infinity to negative 2. Remember, you have to put a parenthesis on the negative 2 and positive 2 to exclude them. Unioned with the middle interval, which is parentheses negative 2 to positive 2 with parentheses, unioned with the last interval, parentheses 2 to infinity. Next, to find the domain of the difference function f minus g of x, the domain of this function is the intersection of the domains of f and g. What do we mean by this? All this means is, what do the domains of f and g have in common? Well, they have everything in common since they're identical. So this is the domain of my difference function. So it's negative infinity to negative 2, open interval, unioned with the open interval negative 2 to 2, unioned with the open interval 2 to infinity. So that is the domain of my difference function, f minus g of x. And lastly, I need to find the domain of the quotient function, f divided by g of x. And the domain of f divided by g is the intersection of the domains of f and g. But you also must exclude all values of x for which g of x equals 0. So when is this function g equal to 0? Well, a fraction equals 0 when the numerator equals 0, as long as the denominator is also not 0 at the same time. So let's take the numerator 7x plus 7, set it equal to 0. Subtract 7 from both sides, we get 7x equals negative 7. Divide both sides by 7. I get x equals negative 1. Now, is the denominator equal to 0 at -1? No, the denominator is only equal to 0 at +2 and -2. So g of x equals 0 when x equals -1. Now, is that in the intersection we found up here? Yes, -1 is in here. So I'm going to have to exclude it from this domain. So I'm going to land up with 1, 2, 3, 4 intervals. They're all going to be open intervals. -∞ to -2 is the first one, unioned with -2 to -1, unioned with -1 to +2, unioned with 2 to infinity. So there is the domain of our new quotient function f divided by g of x. And one thing I want to point out is here is the simplified version of f divided by g of x that we found on the previous page. If you just look at this simplified version, the only problem you would see in the domain would be this one. You wouldn't find out about these two problems. So if you don't like finding the domains this way, please use the unsimplified versions of the functions we found on the previous page, not the simplified versions I've written up here. You can also see that for the difference function, if you look at the simplified version here, it only appears that there's one domain issue of x equals 2. But notice there were two problems in this when x equaled 2 and -2.